This tutorial, I am going to discuss a very interesting and a very famous interview problem, find peak element. So the problem statement is given an array of integer, find a peak element. The array may contain multiple peak element. In that case, return any one peak element. So what is peak element? An element which is greater than its neighbor. For example, in first example, if you see this array, the peak element is 7 as it greater than its neighbor. So it's greater than 4 and 5. And it is the only peak element present in this array. Let's see the second example. In this example, the peak element is 8. If you see this array, it is strictly decreasing. So in that case, first element is the peak element. And let's see the third example. And in this example, if you see, the array is strictly increasing. So in that case, the last element is the peak element. And let's see another case in which all the elements present in an array is equal. So in that case, return any element, as every element in this array is the peak element. So this is the problem statement. Let's think for a moment, what's the best possible solution for this problem. Before solving this problem, let's plot a graph of this array. And in this graph, x-axis represent the index of an array and y-axis represent the number. And by seeing this graph, uh, we say 7 is the peak element. And so now we have plotted the graph. Let's think what's the easiest approach to solve this problem. So the easiest approach is to traverse an array and compare this element with its next element. And if you see this graph, if we compare, is 2 is greater than 3? No. 3 is greater than 4? No. 4 is greater than 7? No. 7 is greater than 5? Yes. So 7 is the peak element. And by using this condition, we found our peak element. And what about this array? Now let's say if the array contains following elements. What about this array? So the array is sorted and it is strictly increasing. So this condition is not satisfied. So we return the number present at the last index. So the number is 7. So it is the peak element. And what about this array in which only one element is present? In that case also we simply return this number 1. So it is the peak element. What about the time complexity? The time complexity of this approach is on. And can we do better than that? Yes. So let's see our next approach in which we solve this problem in O log n time complexity. In this approach, we are going to use binary search to solve this problem in O log n time complexity. So in binary search, we first calculate the mid, and in our case, the mid is this point. So start is 0 and end is, so the length of an array is 5. So end is 4. So our mid is 2. So we reach at this index, and in next condition we are comparing is the element present at mid index is greater than the previous element? Yes. And the next condition is the element present at mid index, which is 4, is greater than 7? No. So it is greater than the previous element, but it is not greater than the next element. So definitely this is not the peak element. And if you see this condition, mid equal to 0 or and mid equal to n minus 1, this ensure that we don't get array out of bound exception. What about if we reach at this index and we are comparing the element with our previous index? So in this case it's not possible. Similarly, if we reach at the end of the index and we are comparing with the next index. So to prevent array out of bound exception, we I have put this condition mid equal to 0 or and mid equal to n minus 1. So let's move to next condition. So this condition is skipped as it is not satisfied, as 4 is not greater than 7. Now let's see the next condition, where is mid minus 1, the element present at mid minus 1 is 3, is greater than the element present at mid. No, this condition is also skipped. So now we assign mid plus 1 to a start variable. So the mid is 2 and mid plus 1 is 3. So we calculate new mid with 3, and what about the value of n? So it is 4, and so the new mid is 3.5, but here we have declared an int, so it is 3. So we reach at this index, and let's again compare. Is mid is greater than, is element present at mid is greater than its previous index? Yes. Is element present at mid plus 1 is smaller than the element present at mid? Yes. So 7 is greater than the 4, and also it is greater than 5. So this is the peak element we have found, and I have returned this number. So this is how we can find the peak element using binary search. The time complexity of this approach is O log n. And let's see the main method. In main method, I have declared an array and I'm calling this method find peak element using binary search, and it returns the result which I am printing here. So in this tutorial, I have discussed two approaches to solve this problem, and that's it for this video tutorial. For more such programming video tutorials, you can subscribe our YouTube channel. You can visit our website, which is https://webrewrite.com. Thanks for watching this video.